All right, welcome everyone. Is this mic on? Can you hear me? Thumbs up? Awesome. So welcome everyone. Thanks for joining my talk. I think it's the most clickbaity title. I'm not going to read all of these abbreviations because that already wastes half of the time. But instead, I would like to give you in the next 30 minutes a quick introduction to web security. And this is not going to be making you all web security experts. But one thing that I want to make sure is that all of the topics that I highlight are topics that I think every web developer should be aware of whenever they build an application. And hopefully by the end of the talk, all of these abbreviations will make a bit more sense to you. But before we start, I would like to quickly introduce myself. As mentioned before, I'm a developer evangelist for a company called Twilio. We do things like APIs to send and receive text messages and other things around communications. And I live in Berlin. But there's one more thing that you should know about me, and that's the beautiful part where I can drop this jacket because it's getting really warm. And this is where the talk gets awkward. All right, so I'm a member of a group called onesie.js. We're a group of onesie-loving JavaScript developers that love to go to conferences and care about the community. I think Flucky is somewhere here, which is the unicorn that is running around. I'm not sure if I see him right now. But you know, like today, we have so many social networks and communication channels, but there isn't really one for onesie-loving developers. So being a developer myself, I did what every developer does when they're frustrated about something not existing. And I built the future great social network called Onesie Live, which is for onesie-loving developers, a social network, which I'm fairly certain will take off. I'm not sure why I don't have high traffic yet, but it will come. And you know, like being a developer, I obviously made sure that this is as secure as possible and doesn't have any vulnerabilities, especially nothing that can be hacked with a banana. So, you know, I thought of everything. It uses HTTPS, and thanks to Let's Encrypt, I don't have to pay a dime for that. It uses HSTS, which is the HTTP strict transport security, which just makes sure that there's no downgrading of the traffic. So this is typically what blocks you from going to google.com when there's a public Wi-Fi with a captive portal, because they're trying to downgrade the connection typically from HTTPS to HTTP. And you know, I don't allow mixed content, so no HTTP content on a website that is served by HTTPS. I sanitize the HTML, so I allow people to put in Markdown, but I will make sure to sanitize it before I put it in the page. And there's no room for SQL injections because I'm not really using a real database, so there's no way to have database injections. And I'm not talking about NoSQL databases because there are NoSQL injections, but I'm literally just using a plain storage because I don't believe this will scale. But turns out that developing secure web applications isn't as easy as I thought. So I contacted my buddy Bob Allison, and he took a stab at the application and kind of and figured out a bunch of security vulnerabilities that I would like to share with you today. And this is where this hood gets really warm, so I'm going to take this off. All right, so if we go to this page, this is basically the login dialog, and I'm going to open the DevTools here so we can monitor the thing. And basically what I'm doing, typing in my super secure password here, and it will just do a normal post request, and afterwards I'll send set an HTTP cookie to maintain the session. So if you're not familiar with cookies, it's just a way that allows you to maintain session state throughout multiple sessions by setting a value either via HTTP headers or via JavaScript. So if we go into the console here, we can actually access that. And so I have one that is called auth token. And this is what is called a JWT or JWT or JSON Web Token. And they're formatted in a very particular way. So if we inspect this, we can see it has three different parts. It has a header, which is the red part. It has a purple part, which is like the payload. And then it has a signature. So that's generated by an algorithm that is specified in the header using a secret. And if we look here, it actually says invalid signature because I was smart enough to not use secret as my secret. But unfortunately, there is a vulnerability in my app around this that we can exploit. And that is because there are different algorithms that you can use to sign your JWTs. And one of them that is mandatory in the spec is none. And what none basically says is that disregard the signature. We don't care about it. And this is more for like transmitting data than like maintaining session or something. But the problem is if we do this, and let's have some fun, we switch the role here to admin. And then I copy this part. And this is just base64 encoded, right? So this is plain data. Don't think this is secure or something. And I will set this as an auth token. Then we will, we can refresh the page and we'll see that we're now in admin mode. And that is because I'm taking the JWT as a single source of truth. So if it says role admin, I'm an admin. You know, I'm not looking this up or anything. And because of that, in combination with the algorithm that is none, we can kind of just switch anything. And I wouldn't have had to log in the first place. I could have just generated this token with any username and sign in as anyone. So how can we protect ourselves from that? So the first thing is, as I mentioned, you can set cookies either via JavaScript or via HTTP headers. And you can declare cookies as HTTP only. And that means that you can't access these via JavaScript. They will still be sent around by the browser, but you won't be able to access them in JavaScript and manipulate them. Additionally, I should have set this as a signed cookie, meaning I won't be able to manipulate this anyways without knowing this, the token that was used to sign the cookie, and as secure, so this is only transferred by a secure connection. But there's another thing I should have done, and that evolves around JWTs themselves. So I'm using the JSON Web Token library on Node, but I'm using an old version, and that one has two flaws that the newer one fixes. And that is, on the one hand, the library should provide you with a way to whitelist algorithms. So in this case, I'm in the secure version of this, I'm saying that I only allow HS256 tokens versus nothing else. And then the other thing is, in this library, for example, if the secret is set to something that is not null, the library will actually not accept none as an algorithm. But that's only in the newer libraries. So the bottom line here is stay up to date because you don't want to be the next Equifax, because that's pretty much what happened to them. Not about JWTs, but about having an older version of an implementation that was known to be vulnerable and them not getting around to update it. So you don't want to be in the news for that. And this is a social network, so we can post stuff. So let's jump back here and actually post something. And I set this as marked, so we can write something like, hi, JSConf Iceland. And if we post this and we look at the traffic, we will see that, if I make this bigger, let's switch this to this. There's an HTTP post request here that actually sends the auth token along and just sends a form data here in the bottom. So this is nice because it's really easy to implement. I'm literally just submitting a form asynchronously. But the combination of form and cookies is also something that can cause a cross-site request forgery attack by attackers. So to give you an idea how this works and what this actually is, so this is pronounced XSS. So sometimes it's written as XSRF or CSRF, but typically it's pronounced CSRF. So if we perform a CSRF attack here, it says you got pwned, and if we get back to the page and we refresh here, we see that actually the attacker was able to post on my behalf on the page. And the reason why this works is that the browser is super eager to send all of these cookies along on every request. And if we look at the code that actually hacked us here, all it does is it on body on load, it will submit the form that we have there. In this case, it's visible, but this could have been also just hidden. And inside there's an input tag with a message we want to send. Again, this could be hidden. It doesn't have to be visible. And then this just submits. So, and this is really the danger about this because the browser is super eager to send this. So let's talk about how we can fix this. So let me find my slides again. All right, so apparently I was hacked twice by this application. So let's navigate back first and talk about what happened here. So when I clicked on the link here, I'm using a target blank link here. And what this causes is that the attacker's page can actually access my page window by using window.opener.location and rewrite that location. So in my case, I was just, the attacker page was just navigating me to another harmless page, but this could just as well be a redirection, for example, to a phishing page that looks like your page. So imagine you have something like a social media page where someone can post a link and you always mark it with target blank. Then someone could put in a page link that redirects that original browser to a phishing page. Luckily, protecting yourself from that is actually pretty straightforward. You want to use the rel attribute and set it to no opener and no refer. No opener basically declares that you don't want to provide access to window.opener, and then there is no refer, which because some browsers don't support no opener, namely IE, and I'm not sure if the newest version of Edge supports no opener, but older versions don't. You want to use no refer as well, which at least will hide the refer URL, so we can kind of protect ourselves from that. Plus, there are some JavaScript scripts that that allow you to kind of circumvent this as well. To get back to the CSRF attacks, the approach here is relatively straightforward as well. You can use a library like CSRF or just implement this yourself. But the basic idea is that you will generate a new cookie called underscore CSRF, for example, where you specify a random token. And then you pass this token once as a cookie, but you also embed it into the page that is supposed to have this, for example, a form submission, into, for example, a hidden input field. And then when you submit the post request, in this case, you will check if the value in the cookie equals the same value that is either passed in the request body, in the request query parameters, or in one of the headers, like the ones in the example, which are the ones that the CSRF library checks for. And if that's the case, then that works. And like you successfully submitted something. If this isn't the case, it's likely someone who performs a CSRF attack against you, because they will be able to submit that cookie, but they're not able to read that cookie since the browser auto-submits this, meaning that they will not be able to pass this as a header additionally. All right, let's talk about Little Bobby Table's younger brother, which I call Sammy. And the reason is to first give you a background about Little Bobby Tables, if you're not familiar with that. It comes from this XKCD comic, which is a joke about SQL injections by a family of hackers who named their kid like a SQL injection, and the principal being mad because they lost all of their student records because they weren't sanitizing the input. Now to get to XSS attacks, does anyone know what this source code is from? I would be really impressed if someone knows this by heart. So this is the Myspace worm, or Sammy worm. Some of you might be familiar with this. For those who are not familiar with this was an XSS attack from 2005 on Myspace, which would basically repost this code, add Sammy as your friend, and post that Sammy is awesome. That's also how they caught him, because if your XSS code points at your Myspace profile, that's not a smart idea. Maybe now, because Myspace isn't much of a thing anymore, but especially at that time, that wasn't a smart idea. But the cool thing about this attack is it shows a couple of things that people use to circumvent XSS protection, because Myspace actually had XSS protection, and yet that wasn't enough, because one thing that they said is they don't allow script tags, they didn't allow JavaScript colon in URLs and stuff, but they did allow inline CSS. So Sammy just created a div tag that had a style in it that used background URL and then put JavaScript in there. And because he wasn't allowed to use quotes in there, he basically took all his code, wrapped it into an eval, and put the code itself into another HTML attribute, and that would then just be evaluated. The other thing is they blacklisted words like inner HTML or on ready state change, which is something that is used by XML HTTP requests, so AJAX requests before there was fetch. But what Sammy just did is he just turned this into strings, split them by a plus, and then so basically reconcatenated them and evaled the whole thing, which equals to the same code, but it's harder to regex against that. And then there's the other thing, because if you say that, like, well, I could block eval, and then that's fine. Those are all ways to evaluate code. The last one is from a project that I'm not sure if I can name the name, because I'm not sure if it violates the code of conduct, but talk to Martin Klepper over there, and he can probably tell you the name, or I can tell you the name afterwards. But basically the bottom line here is there are a bunch of ways to write the same code in JavaScript. So you can't just block like a single word or like blacklist certain words, because that doesn't help you. So blocking XSS is not trivial, and obviously I have a demo for that as well. And so I told you I'm using Markdown here, and I'm using a library called Marked. And if you're not on the latest version, but like a few versions back, so not really old, even though it has a function that allows you to sanitize stuff, so we can do stuff like alert 1, and this will not work, there is a security vulnerability in here. So we can create links, right? And I can do something like click me. And in here, if we would write JavaScript alert hello JSConf, then I'm going to copy this. This doesn't work directly because the sanitizer is smart enough to do that. But we can play around with this, and shout out to Guy from Sneak, who actually showed this to me. Let's do some fun stuff with encoding. So ampersand #51 semicolon is literally the same as a closing parenthesis. And similarly, a colon is ampersand #58 semicolon. And I'm going to copy this. And if we look at this, this is already a difference because suddenly we don't have the closing parentheses anymore. So we're getting there. Now we can use a sort of quirkiness in the browser and actually write this here. And what this will do, let's first try this. It works. And the reason why this works is that the browser, so first of all, the HTML sanitizer will see this and it doesn't see JavaScript colons, so it's like, I'm fine with that. But the browser will see, oh, you have an ampersand, a hash, your number. I think you just forgot the semicolon, so I'll be a good guy and insert this. Then everything afterwards turns into JavaScript. So this semicolon is valid JavaScript, so it doesn't complain about that, and then we can do anything afterwards. So we've seen this works. And the bottom line here is encoding can be dangerous. Don't trust any code that your user can put in because they can just modify it in like different ways to kind of get around that. Also CSS, don't trust CSS. I don't have time to dig into that now, but don't trust it. And Jake Archibald actually just tweeted about this 2 days ago again with a new blog post. Really don't trust CSS. There's a bunch of stuff you can do about it, and I highly recommend you to check out this tweet, or like the blog post in this tweet. Let's talk about another thing, and that's JSONP. So JSON with padding, it's being used less these days, but basically it's a way to circumvent same origin policy. So if you want to request some data from a different domain, you could do this. And the way it works is you define a global function. If you would use something like jQuery's JSONP method, it would define this for you. But it's basically a callback function that has to be global, where you expect the code to, the data to be passed into. And then you inject a script tag with that JSONP URL and pass in as a callback, for example, or any other parameter depending on the endpoint. You define the name of the function. In this case, it's called got_posts. And what this will do is the JSONP endpoint will take that name and then wrap the data into a function call with that name. Now, if you use that, but you write poor JSONP and combine that with the XSS attack, now this is getting fun, because my JSONP endpoint does not verify what I pass in as a callback. And that means that we can, I'm in the wrong tab, we can generate arbitrary JavaScript here. And this gets really fun. I'm going to first show it to you and then explain what's going on. So this is a bit of a longer code snippet, so I'm going to copy this. So I'm going to press this and then click this button, and nothing happens. But if I refresh the page, we get this. And I can refresh as many times as I want. It will stay like this. So the reason why this is happening is if we go to application, I installed a service worker. And if you don't know what service workers are, they're an API from the browser that allows you to handle the network proxy, so that you can. It's made for things like offline available apps, so you can cache your websites and your resources and kind of handle which ones you want to cache and which ones you don't. But it can pretty much do anything because it can intercept the network requests, right? Now the browsers are smart enough to make sure that this can only be, like a service worker can only be installed from your domain. But if your domain has something like a vulnerable JSONP implementation that allows you to generate arbitrary JavaScript code hosted on your domain, then you have the problem like this. So we can actually see the callback parameter here is really long because it's literally the entire JavaScript that I wanted to generate. And if we prettify this here, we can see what's actually happening. So I'm creating the service worker script, and then the entire data, because I don't really care about it, is commented. And in here, what we do is we just kind of reply always with a hacked and a script tag injected. But this is an obvious attack, but you could do it in a less obvious way as well, right? You could actually fetch the page, inject a script tag, and then send that to the user, and the user will not recognize this. Especially not a common user who doesn't have the dev tools open and checks what service workers are installed. I mean, how often did you do? Let's see, I think they still have that checkbox or something. Oh, it's down here. So there's a drop down here called service workers from other domains. That's a lot of fun. Open that and you will see how many people actually install service workers. But you're not reading that code, so you have no idea what these service workers do. So it's sort of a dangerous attack. Let's actually remove this because else I forget about it. Unregister. So if we reload this now, this works, but you obviously don't want to explain your customers. Please go to your browser and then click on application in the dev tools and then click on unregister on this thing called service worker. So far we've seen different XSS attacks, and we should fix all of these and also all the other attacks that we have in there. But there is a new superhero in town that allows you to protect yourself at least against some of these. And that's called Content Security Policy, or CSP. And I have a demo for that, and this is the exact same page. All that I'm doing is I'm injecting an HTTP header, and we can see that if I click on any of these and refresh, nothing happens, no difference. The only difference is I'm not showing some pictures here. And if we open this and go to the console, we'll see we have a bunch of errors. And that's because it says that it violates the following content security policy. So what does that actually mean? So I said content security policy, it's just an HTTP header that you can define rules that the browser should play by for your resources. So this can be things like, by default, anything hosted on my domain is fine, but for scripts and styles, I only want to have things that have the following nonce. And this nonce changes on every request, so this can't be hard-coded by the attacker. And that means that no more inline scripts unless they have an HTML attribute called nonce. Similarly, no inline styles or anything, and that's why the alert 1 or these XSS attacks don't work. I'm blocking objects here. Image source, I'm only specifying self and api.adorable.io, which is what I use for the user icons. Font source, I only allow Google fonts and self. I block all mixed content, meaning no HTTP content in my page. And then I specify report URI, and this report URI will be pinged on every violation with an HTTP post request. There are tools that you can point this against, but you can also point this against any endpoint on your server, and this will report it. There's also a report only flag, and that one allows you to say that you want to only get the information that something has been violated, but you don't block the actual content. And this is great for kind of transitioning into it, especially if you want to test this first in a local environment or something. But the important thing here is to keep in mind is that CSP should not be your security policy. It should be, or security strategy, it should be your safety net. Because writing a really strong CSP is hard, and there's a great paper by Google about this, sort of about the dangers of this. And meaning you should only have this as a safety net, but you should still care about XSS attacks and similar things. Couple of other things that you should look out for. You should avoid clickjacking by disallowing framing. I think most websites don't have a legitimate reason why they should be allowing to be iframed. And if you do allow iframing, what an attacker can do is they can place your page with an opacity of 0 above their page and kind of line up buttons so that that a user thinks they're interacting with their page, but they're really interacting with your page. And so this is what people could use, for example, to if you want to like a page or something like that, which Facebook blocks iframing, but you could do something similar. Also, don't show versions of front-end libraries and servers. So there are things like unpackage and stuff that are really useful to develop things, but if you show a version number in your HTML page or in your HTTP headers, like, hey, I'm using Express version, whatever, this gives an attacker the right idea of what security vulnerabilities to test out, and you don't want to make their job easier. And then check for types of input, because there can be things like NoSQL injections. If you expect a value to be a string in an HTTP, in like an HTTP body or in a query parameter, check that it's really a string. Don't just assume it, because there are things that, some parser libraries that will parse things like objects as well. And if you do that, the result is that you could, for example, have a NoSQL injection. Other things, consider security audits, especially if your code base has never had a security audit. If you don't have an internal security expert, contract one, because there's so many things that is really hard to kind of keep up with, that this is really helpful. And you learn yourself a lot as well if you look over their shoulder. That's how I learned most of the stuff, was when I had to go through a security audit with a feature. And then stay up to date with versions, because as I said, you don't want to be the next Equifax. Greenkeeper is a useful tool, but there are other tools as well. Similarly, use a tool to detect security vulnerabilities in your dependencies, because you can write the most secure code, but if your dependencies are vulnerable, that sort of defeats the purpose. So Sneak is one of them. I like them because they also provide patches for things if they're too late. So for example, Marked still has a fixed that vulnerability that I showed you, but they still have a vulnerability about data URIs, and that still didn't make it into the package, at least last I checked. But Sneak, for example, has a patch for that. But there are other tools like Node Security Project and etc. that check for this as well. GitHub, I think, scans your package JSON now as well and tells you about vulnerabilities. So to wrap this up, use signed HTTP only cookies. Be skeptical of JWTs. Don't treat them as a single source of truth. Use something like, use rel no opener and no referrer on your target blank links. Use CSRF tokens. It's really easy to use, so there's no real excuse to not do it. Blocking XSS isn't trivial, so always think about, like, whenever you let the user input anything, or if you have query parameters or something, always think of these and make sure that they can't cause harm. Be aware of encoding, because there are a million ways to write the same thing. Be careful with JSONP. A JSONP endpoint should really only accept word characters in a callback and nothing else. Use CSP as a safety net. And most importantly, stay up to date. So I put up the slides here, and I'm going to tweet the link in a second so you can check them out again. Similarly, the whole source code of the website is on this URL, including different README files for every of these vulnerabilities that I showed you, plus a couple of others that are in there, including resources that are interesting about the respective topic. And with that, I would like to thank you all for your attention. I'll be around for the rest of the day wearing likely this jacket instead of the onesie, because this is really warm, even in Iceland. And yeah, come by, ask me any questions, and thank you for your attention.